Hi guys, so for today's lesson we're going to be dealing with solving inequalities. So pretty much an inequality is when you've got a number sentence and you're dealing with like this sort of sign, so that's less than or greater than or equal. So when we're dealing with these sorts of signs. When you're solving an inequality, remember to solve something, like for example this equation here, to solve it would be to get this x by itself. So when you're solving an inequality, we treat them very similar to normal equations. So you use opposite operations to both sides of the inequality, and you also want to get that pronumeral, that x by itself. So they're the main rules that you need to remember. Okay, so an example is here. When you're solving this one, we're getting this x by itself. So first up, we rewrite the equation, or the inequation in this case, and we want to get this x by itself. Well, we're going to move the plus 5 first by minusing 5 to both sides, and then we're going to get rid of this 3 here by dividing both sides by 3, and we get that 15 divided by 3 equals to this 5. So we get x by itself. Notice that we're no longer using an equal sign. We're using this greater than or equal, and that just stays the same each time. So treat that like an equal sign, but obviously it's not in this case. It means x is greater than or equal to 5. Okay, so however, this process does go wrong when you have to multiply or divide both sides by a negative number. So this rule that we've got here is really important. This is an example, a really good example. So I've got here, which I've just circled, I've got that 10 is greater than 5. And I completely agree that is true. 10 is bigger than 5. 10 is greater. However, if I multiply both sides by a negative number, so say I'm multiplying by negative 3, 10 times negative 3, that gives us our negative 30. And we've got 5 times negative 3, that equals negative 15. We end up getting this as our next line. Is negative 30 greater than minus 15? And the answer is no. Negative 30 is much less than negative 15. Like, it's a lot more negative. So that's completely false. So suddenly we go from a true equation to a false equation, and that's exactly what we don't want. We want to always be working with true equations. So what we actually need to do in this case is to flip this sign to the other direction and say that negative 30 is less than negative 15, which is true. So the rule of thumb is that when you multiply or divide, the same thing happens with division. When you multiply or divide both sides by a negative number, see this negative 3, that's when you have to remember to flip the inequality sign to the opposite direction. Okay, so there's our rule here. Okay, so let's try an example of this. So solve negative 10x plus 2 is greater than negative 18. So we're solving this inequality right here. Okay, so let's give this a try. So first up, let's have a look at it. Well, we want to get this x by itself. So we get rid of the plus 2 first by minusing 2 to both sides. And that gives us negative 10x is greater than, notice we just kept it the same, is greater than negative 20, because minus 18 take away 2 is negative 20. Now we want to get rid of this minus 10 here to get x by itself by dividing by a negative 10. We're dividing by a negative here, so we need to flip the sign. So negative 20 divided by negative 10, well, 2 negatives make a positive when you're dividing. So, and 20 divided by 10 is a positive 2 in this case. So we need to think to ourselves that we get our x by itself, so we bring that down. But this sign has to swap to the other direction because we're dividing by that negative. So really important step to remember. Okay, some harder examples. So let's solve this inequation here and represent your solution on a number line. This is a really important request of questions when you get tested on this topic. They want your solution on a number line. So that is very similar to what we were doing last lesson. We're putting our inequalities on a number line. Okay, so working, let's deal with our equation first. So I rewrote that, and obviously I see the brackets, these brackets here. I want to expand those. So remember, when you're expanding, you've got your two lots of multiplication happening here. So 3 times 1, that gives us our positive 3. And next is 3 times negative 2x, which gives us our negative 6x down here. And our minus 15 comes straight down. And also the greater than or equal sign comes down as well. Okay, next up, we're trying to get our x by itself now. We've got to get rid of the minus 6 and the 3. We get rid of the 3 first, it's further away. So we take away our 3 from both sides. And then we get that minus 15 take away 3 is negative 18. Next up, we've got to get rid of the negative 6. So we divide by negative 6. And that's got to set alarm bells off in your head that you're dividing by a negative, so you need to flip the sign. Negative 18 divided by negative 6 makes a positive 3. Remember, 2 negatives makes a positive when you're dividing. And we've got our x by itself. So we've got that x is less than or equal to 3. So x is smaller than or equal to 3. So on our number line down here, we're wanting to have our 3 in the middle. And then we'll just draw a few other numbers on our number line on either side. And we want to colour in the circle because it can be equal to. And we want everything that's smaller than 3 because x is definitely smaller than this 3. So all the numbers that are smaller are all the ones down here. So this is the way that the arrow points. And we are done. We've got our solution on a number line. Question 2 is a bit of a word problem. Okay, so Matt wanted to buy 5 oranges at X dollars each. So we don't know how much the oranges are. They're X dollars. And he wants to buy 2 cartons of milk at $3 each. So 2 lots of $3. He had $12, but that was not enough money. So it's a really important idea there. So firstly, we want to determine the inequality that represents this situation. So we want to figure out an inequality. So that means like a number sentence that uses these greater than or less than symbols. Okay, so first up, the working. Well, he wanted to buy 5 oranges and they're X dollars each. So you want 5 lots of oranges or 5 times our X because that's the value of one of these oranges. So that's one of the first things we're going to be writing down, 5 oranges or 5X. We've got 2 cartons of milk. So that's going to be 2 lots of $3 because they're $3 each. So that's the next thing we'd write down. And obviously we're wanting to buy both of these things. So we're going to be adding these prices together. Now we had $12, but that was too small. So this whole thing is going to be bigger than $12. So we didn't have enough money. So it's greater than $12. Notice that it cannot be equal to $12 because if it was equal to $12, he would have had enough money. So it's strictly greater than $12. It had to be bigger than 12. So that's the symbol we use in this case. Let's simplify this thing here. Only thing we can do is 2 times 3, and that makes our 6. And then we get our final inequality, as simple as that. You just have to think through the situation. Okay, question B is to solve this inequality. So this one here in our previous answer, solve it for x. So that means get x by itself. And what does this solution tell us? We've got to think, what that value of x that we found, what does it mean? So let's solve it first. So there's our inequality again. We need to get x by itself. So we're going to minus 6 to both sides. 12 take away 6 is 6. And we're left with 5x. Then we're going to divide by 5. Notice we're dividing by a positive 5. So the inequality symbol is going to stay in the same direction. And 6 divided by 5, well, you can't divide 6 by 5, so keep it in improper fraction form. So it's going to be 6/5 or 6 over 5. You can do that in a calculator to get that if you're having trouble with it, or that's on top and that's on bottom. Simple as that. That division sign is like a fraction symbol. So 6 over 5, just using these numbers. Simple as that. So note, now we've got to think about what does this x mean in this context of the question. Well, if we go back to our original kind of definition for x, what does x mean? X was the price of the oranges. So x is how much an orange costs. So we've got that x is greater than 6/5. Well, we're working with cost. So let's deal with the decimal version because with money we like decimals. So if I press the SD button on 6/5, I get 1.2. So that's the money. That's our value for x as well. So x is greater than 1.2. Well, 1.2 in terms of money or the price of an orange, 1.2 is the same as $1.20. And we're saying that X is greater than $1.20. So that's saying that the price of an orange, which was X, has to be more than $1.20. So that's why I didn't have enough money. The oranges are too much. They were more than $1.20 each, and he couldn't afford it if they're more than this amount. Okay, I hope this helps. Good luck with the questions. Bye.